After getting this knowledge of alkane, now we are focusing on next part, that is the unsaturated one. In case of unsaturated, we are saying that at least one bond is either double bond or triple bond. Then we are calling that as unsaturated compound. Now, if one bond is double bond, this is I am going to show here. This is double bond. Then compound is termed as al, and we are changing out prefix, suffix. Suffix means the word which is added at back. Here we are adding out ane. Now we are adding out here ene. So we are adding out suffix as alkene. The formula is CnH2n. So here we are getting CnH2n plus 2, whereas here we are having formula only CnH2n. That plus 2 is removed. Why? See, there is carbon carbon. So as two carbon atoms are there, we are calling that as ethene. Now valence is satisfied by single bond, but now I have to make here double bond. If I am making double bond, then carbon will have 5 bonds. It is not permitted. Carbon should have only 4 bonds, and therefore I have to remove this bond. So here there was already hydrogen and hydrogen. So as I am removing this bond, this hydrogen is gone, this hydrogen is gone. So what is remaining? That 2 hydrogens are less, then only double bond is possible. So I am removing out this 2 hydrogen. So whatever plus 2, we are writing here 2n plus 2. So whatever this plus 2, I have to remove here. Then this is the formula of alkene. So suppose C2, like that in this case, then H should be 4. So 1, 2, 3, 4. So like that compounds are here. So you are aware of now alkene. What is the category of characteristic of alkene? At least one double bond should be present. Now here this general formula is given when alkene is there. If second double bond is present in series, then we are calling that as diene. Third double bond is present, then triene. But right now don't go at that level. Only consider one double bond is there. Then this is the general formula. Now in this case, particularly alkene, the first member is absent. In alkane, that series we discuss first member is C1H4, that is methane. But here we are not having methane. Reason is obviously you are aware that what is alkene? There should be at least one double bond between carbon and carbon. So double bond should be there between carbon and carbon, then minimum 2 carbon atoms should be present, and therefore this series starts with ethene. So here the member is ethane, here similar member I should show ethene and not methane. So methane is not possible because there is only one carbon, but when 2 carbon atoms are there, it is possible. So first member is ethene, then propene, butene, like that. Everywhere we are adding out suffix as ene. Now what is the characteristic of this double bond? Say, you are aware now that double bonds, whenever I am showing double bond, one bond is sigma, another one is pi bond. Now in case of sigma bond, it is strong. In case of alkane, as there is only carbon-carbon single bond, only one bond, that means it is sigma. So alkanes are not showing that reactivity. Say, I am not showing alkane is not showing reactivity. You may say methane, we are using as fuel. It is combining with oxygen and giving us carbon dioxide plus water. It is shown, but it is not very reactive. Whereas alkenes are somewhat more reactive than than alkane. Reason, say there is only sigma bond between carbon and carbon, which is difficult to rupture. But when pi bond is there, it is very easy to rupture, because bond breaking energy, that bond dissociation energy of pi bond is very less. we discussed that pi bond is formed because of lateral overlap of orbitals, pure orbitals, particularly here in case of carbon, they are pure p orbitals. And the overlap is not that strong. It's very easy to rupture bond with lower dissociation energy, and then see what happens. This bond is breaking out, so two sides are open because carbon should be tetravalent. Already carbon, in case of double bond, it is present. Then carbon is having these two valencies are not there. But now the moment I am removing this bond, there are two valencies open. So there is now chance that we are getting 4-4 bond. And so here, whatever the compound, suppose I am adding HCl, then H is added to one part and Cl is added to one part. And this way we are getting HCl is added. So alkene are giving this type of addition reaction. But we had to discuss this topic in later phase when we are discussing about types of chemical reaction. Now here alkane is not giving any addition reaction, but alkene, they are giving addition reaction very easily. Alkenes are more reactive than alkane because pi bond is easy to rupture. Pi bond is having very low bond dissociation energy. Now this is about alkene. Same way, if triple bonds are present, then that compound we are calling as alkyne. So here we are adding out suffix as YNE. So this is alkene, double bond. Any one triple bond is present, it is called as alkyne. Now alkyne is having general formula CnH2n, and now you are aware as one more pi bond is formed, two hydrogen atoms are removed. So from this formula, previous formula, I have to remove two hydrogen, so -2. So now you can compare general formula for alkane, it is CnH2n plus 2. For alkene, it is CnH2n, so 2 carbon less, two hydrogen less. Now here CnH2n minus 2, so whatever the total hydrogen is there, less than that 2. So again first member is ethyne. So this way these names propyne, butane, like that names are there for alkyne series. You are aware that we are using various compounds in this category also. For example, ethene. Ethene is undergoing one reaction, we are calling that as polymerization reaction. I am not giving detail here, just I am giving you example that ethene is undergoing reaction that is called as polymerization reaction, and we are getting polymer of ethene, and you are using that is polythene. Whatever the plastic, transparent plastic bags are we are using, they are called as polythene bags. So it is formed because of ethene. Then one of the important member of ethyne, we are calling that as acetylene. That is very reactive in nature. It is combining with oxygen, and it should be actually called as ethyne, but general name we are calling acetylene. So it is giving flame that is called as oxyacetylene flame. That flame is having very high temperature, gas welding etc. We are using this type of high temperature flame for that is used as gas welding. So like that various compounds in these categories we are using in sometime daily life and sometime not daily, but in industries this type of things are required. So this is the classification of open chain compound. So basically we can say open chain compound I have to consider alkane, alkene, alkyne. But one step is there that we are calling saturated compound and unsaturated compound.